So today we'll be looking at how you can add temperature to icoFoam solver. icoFoam solver is actually a solver which is inbuilt in OpenFOAM. It just solves the momentum equation, but now we are going to add a passive scalar. We'll take the example of adding temperature to that and see how you can actually compile your own solver during this process. Now let's start. I'll open this terminal. Inside this terminal now I'll select, because I have actually two different versions of OpenFOAM, I'll select one. Then let me move into the folder where all the solvers are present in OpenFOAM. So the solver we are going to copy, we are going to base our work on, is called icoFoam solver. Now you can find that solver inside incompressible. What do you have in here? icoFoam, yeah. So then so you can see this, we are going to copy this solver into our directory and rename it, because we are going to work on this solver and add temperature equation to it so that we can solve a scalar transport as well. So let's copy that, and I will be copying that to a directory and rename that to new icoFoam. Now let me move on to the folder where I just copied. Yeah, so this is the one I just copied. Now let me move into that. So the name of my solver is going to be new icoFoam. You can rename your solver anything you want. And if you are just looking into how you can add temperature to icoFoam, then there's this wiki page which I will be linking in the description below. You can check that out and follow the steps if you need it, or if you follow this video tutorial, then it would be easier for you. Now let's see what are the files inside this. Okay, so there are 3 files inside this. So this is the main solver we are using, and it's currently called icoFoam.c, but now I want to rename this to new icoFoam.c. Let's do that. icoFoam.c, I'm renaming that to new icoFoam.c. Now let's see. Okay, these are the files that we have now. Let's look inside the make folder. There are 2 files inside the make folder. Now first thing you need to do is change some parameters or something inside this file. Let's see what's inside. Okay, so there are only 2 lines of code inside this file. So the first one is the name of the solver itself, and the second one is the location where the executable of this solver is going to be built. So what should we do? The first thing we should do is rename this, and since the name of my solver is new icoFoam.c, so this is going to be my new name, and what you need to do is you need to rename this as well. Another thing to notice here is that you are trying to write this executable onto this new folder, which is form app bin, this one. Now if you might not have the permission to write onto this folder, so what you can do is you can use this location instead of that. Using this, you should have the permission to write it over there. Also, one thing to notice here is while renaming, I have renamed my file new icoFoam.c, but this .c extension is for a simple C style file, but the OpenFOAM needs a C++ file, so I think we need to rename that into a C++ file. So you should do something like a capital C at the end. Now, yeah, so you should check this. After doing that, now let's look inside the file itself. So this was the solver. So this was the solver which we copied. So nothing is changed up until now. Let's change this thing because now our application's name is new icoFoam. New icoFoam, and you can change the description as well. Added the team temperature solver, something like this. Let's move down. So this is the header files that was included inside the solver. We do not change this because we need that. And if we see this, if we go down, we see that. So this is where the loop has started for integration. Now we do not need to change that. Okay, this is the momentum predictor. This is the PISO loop, which means you are correcting the velocity. So right after your velocity is done, that means here, your velocity is calculated here. So before you write everything, you need to now have an equation. You need to have a new equation to solve, which is going to be the temperature equation. Let's write it in here then. You have to write it in here. So what you need to do is either you can copy this equation and change the parameters to change these things, change this velocity to the temperature, and make your own equation. You can write as well on your own. Let's see. So we copy this part, which is the momentum equation. We copy this, and after we have solved for the velocity, we try to solve for temperature as well. So at this part, I'll write a comment. Here the velocity is already calculated. Now starts the temperature equation part. Let's do this. So at this part we paste this, but so if you see this vector matrix equation, and this is the name of the equation. Now we are solving for temperature, then let's change that to TEQN, which means temperature equation, this one. After that, it's saying finite volume vector matrix, but we are not solving for a vector, rather we are solving for a scalar. So scalar. Now this finite volume method, we are using this namespace, and we are solving for a difference in solving for a derivative of time, and what needs to be here, we are solving for temperature, so you put T in there. Now let's look at the equation what we are solving so that we can formulate our equation here. Let me see. Okay, if you look at the equation, then equation of what we are trying to solve here, what we are trying to add, Okay, the momentum equation was already there. Now we add temperature part. So what's the temperature equation? The general temperature equation is like this: rho Cp, total derivative of temperature, is equal to K Laplacian of temperature plus this diffusive term. So we are not looking at this, and if we normalize this, if we take this here, rho Cp comes here, and this is nothing but a thermal diffusivity. So the scalar transport equation would be, this is a derivative in time plus you need a divergence and this is the flux of temperature now, the thing we are trying to solve, minus rho alpha Laplacian of temperature is equal to 0. Now this is the equation that we are trying to solve. So there are 1, 2 and 3 parts, and notice the sign here and here. What you see here is a flux of the scalar field, and this is the diffusion term. So these are the 3 equations that we need to input into here. Okay, this is the first term and this is the second term, but we need to have a flux of temperature in here. So that would be nothing but this thing. Now what's being diffused is temperature, this part, and what's the diffusion coefficient? We say that dt is the diffusion coefficient for this thing. Okay, now this is the equation that we have. After this, what we need to do, we need to solve this equation, which is going to be dqn dot solve. Let's solve. Okay, if you save this, then we have everything. We have added the equation that we needed to solve. But let's look at the equation from start. Okay, so this is the momentum part. The momentum part ends here, and we added this part, which is for temperature. Okay, this is done. Now if I close this, and now let's see. Okay, we have changed. We have added the equation into icoFoam. This part is here. Now we need to look into create fields now. Let's see what's there. Okay, the create fields contains the transport properties. It's basically saying that the viscosity which you need for momentum equation, you get that from a dictionary file, which is the transport properties dictionary file, and you look up for new. Now we have added, let me show you in here. So if you look here, we have added this dt, which is thermal diffusivity. Now we need somehow to provide that thermal diffusivity value, so we need to add this part in the dictionary file. So we will be doing that now. Now you can just copy this, but we know that we need a new value which is dt. Can change this to dt. Now we do not know what its dimension is going to be, so you can comment that does not, and we need to look up for dt and save that. Anything else? So we are looking at create fields attach this header file. This header file actually creates the field in your time directories. So this is the pressure field it's creating here. You can see this is a volume scalar field. The name is P pressure runtime time name for each time, and it has mesh dependency and input output object. It must read the pressure field and it auto writes the pressure field. Now we have added the temperature equation, but we do not have anything like this for temperature, so let's copy this. Let's copy this thing and paste it here after the velocity field is created. Okay, but let's change this reading field. Okay, we are trying to read temperature now. Now temperature is a volume scalar field. That's fine. We need to change this to temperature. This is good. We must read it and we auto write it. Okay, now let's comment this for temperature field. Save that. Okay. Okay. I've saved it. Now we have done everything that needs to be done for this solver. Now let's compile it. Now to compile it, you first need to check whether the makefile has any previous builds or not. So well, it does not have any file, but you can just run wclean. Okay, now after that we make wmake. We run wmake from this directory, and you have to remember where we are at the base of the solver. So if we run wmake, okay, it's making dependency lists. While it's compiling, let's go into the location where we pointed it to save the executable. So that was the location user app bin and C. Okay, so this is the executable that this compiling build. So we are good. Now with this you have actually build your own solver using the icoFoam. Now to check whether this build was okay or not, you can first run new icoFoam help, which is basically the name of your newly created solver. It can be anything. Mine was new icoFoam. Yours could be anything. You could have named it anything. You just need to check whether the build, this is present or not. And you can check it this way as well. If you hit this, it would say the new icoFoam is the application, and the options that you can include are these things. So yeah, we built it correctly and it's working. And after this, we can also check whether this works correctly or not by importing a OpenFOAM case file and running the case with the solver we built here, which will be the part of next video. Thank you for listening. Thank you for joining me. Stay tuned for the new contents and keep learning.